Example number 8. ln of x minus ln of x minus 1 equals ln of 12. Okay, so usually I would say 9 times out of 10 we want to make it 1 log equal to 1 log or 1 log equal to 1 number. Why isn't this 1 log equal to 1 log? Because on this side of the equal sign we have 1, 2 logs. How do we fix our problem? We know some properties of logs that say that subtraction outside is actually division inside of 1 log. And so ln of x minus ln of x minus 1 we can condense down into 1 ln of x divided by x minus 1, and that's going to equal ln of 12. Once I have 1 log equal to 1 log, then I am ready to base both sides. Now, ln, I don't see my base chilling there. But who is my base on ln? I'm supposed to know he's base e, which is why we are going to e both sides. E raised to the ln cancels and x over x minus 1 falls out. That's going to equal e raised to the ln cancels and 12 falls out. Next, we are trying to solve for x. We cannot solve for x while he is trapped in the denominator, which is why we should clear our fractions. Multiply both sides of the equal sign by x minus 1. X minus 1 does need to be in a parenthesis. He cancels here. That's why we did that. And on the other side, I should distribute my 12. For an x equals 12x minus 12. Next, we want x's on one side, numbers on the other. So minus 12x minus 12x is going to give us, oh my, that is strangely uphill. Negative 11x is equal to negative 12. To finish solving for x, we divide by negative 11, divide by negative 11 to get that x equals positive 12 elevenths. Then we check to see if our answer makes the inside of an original log 0 or negative. So 12 elevenths in place of x is a positive and not 0. What about 12 elevenths minus 1? 12 elevenths minus 1 is 12 elevenths minus 11 elevenths. 12 elevenths minus 11 elevenths is 1 11th. It's not 0 or negative, which is why we get to keep this guy, and we get solution set 12 elevenths. I guess I could take my 12 elevenths and make him a yucky decimal. So let's say or x is approximately, usually when I give two answers, I don't solution set. So let's do 12 divided by 11, according to my calculator, is 1.09090. Next to the 9 tells him to stay. And then you would circle these two things. Now, 12 elevenths, I wouldn't usually make a yucky decimal. Directions did say to make decimals if necessary. I would say we usually make decimals for things like we did earlier, which is ln of 4 divided by ln of 3, or even the 9th root of 3 divided by 2. So last thing, the computer's going to have you solution set the yucky decimals. I don't really want you to solution set the yucky decimals. I want an exact answer and a decimal approximation. So maybe I should nix this one. Okay. Example number 9, log base 2 of x plus 4 plus log base 2 of x plus 1 equals 2. This guy, again, we need him 1 log equal to 1 log or 1 log equal to 1 number. Now, when you have a number floating around all by itself, that usually makes you the second one. You need 1 log equal to 1 number. Because even if, like, I moved this guy over, it wouldn't be 1 log equal to 1 log or 1 log equal to 1 number, because this 2 could not be condensed with the log base 2 on the other side. So, again, when you have a number floating around on the outside, this is what tells me I need to have it 1 log equal to 1 number. I know from the properties of logs that addition outside is multiplication inside of 1 log. So x plus 4 times x plus 1, all inside of 1 log base 2. That's equal to 2. Once I have 1 log equal to 1 number, then I am ready to base both sides. I am writing my 2 big and down because we're turning what we already had there into an exponent. 2 raised to the log base 2 cancels, and x plus 4 times x plus 1 falls out. And 2 raised to the second power is 4. And when we are factored and not equal to 0, we are supposed to know that we need to multiply it out. X times x is x squared. My outer is plus x. My inner is plus 4x. My last is plus 4 equals 4. I have some like terms to combine, and then because I'm quadratic, I want to make one side equal to 0. So x squared plus 5x equals 0. And when we only have 2 terms, especially when we have 2 terms and we're solving, we need to look for a GCF first. X squared and 5x do have a GCF. Their GCF is x, which is x times x plus 5 equals 0. And then I set each factor equal to 0 and finish solving. X equals 0 and x equals -5. And then I need to check if my answer or answers make the inside of an original log 0 or negative. So when I'm checking 0, 0 plus 4 is positive, 0 plus 1 is positive, so I get to keep 0. What about -5? -5 plus 4 is a -1. Bye-bye, he gets thrown out, and I get solution set 0. Now there is no yucky decimal to make for 0, he's just 0. Solution set 0. Okay, number 10. Oh, I think I should pause my video, then we'll do number 10.